In this video, what we're going to do is to graph sine functions. This particular method is also applicable to cosine function, not only to sine. So whatever is the function, whether it is sine or cosine, you have to follow the same steps, which I'm going to show today. So the first one is f of x is equal to -3 sine 5x minus 4. As I mentioned, I'm going to show all the processes today. And whether this is sine or cosine, you have to follow the same procedures. So the first step actually is to find our a, b, c, and d. As you can see, this is the general form of our sine function, where a is before the sine and b is before the x, and we have c after that, and plus d. Now c is there if you have open and closed parentheses, otherwise it will be 0. And later, I'm going to give an example. By the way, the first one is an example of that, where C is equal to 0 because the open and closed parentheses are not there. So we have to find our A, B, C, and D. So our A is -3, our B is 5, C is 0, and our D is -4. Now C is 0 because, as I said, we don't have the open and closed parentheses. And next to this is to find the minimum. The minimum is actually equal to D minus the absolute value of A. And the maximum is actually D plus, change minus to plus, the absolute value of A. And the period is equal to 360 divided by the absolute value of B. Okay, so our minimum is equal to -4 minus 3, because the absolute value of -3 is actually 3. So it is -7. And for the maximum, we have -4 plus our A, -3. Okay. So -3 of, the absolute value of -3 will become 3. So to avoid confusion, I can do like this, right? It's here. So actually, this will become -4 plus 3, because the absolute value of -3 is equal to 3. So the answer is -1. Here, let me just show this. This is actually equals, guys, for you to avoid an error, press a space if you want to write an equal sign without solving it. So you have to put space. See, you can go out. If you have equals, for example, and then we have x here, it will create some error without a space. So space equals, this is our D is -4 minus the absolute value of -3 actually. So this becomes equals -4 minus 3, right? Because the absolute value of -3 is +3. So that is why the answer is -7. So let me just put this one here, so you can see what I did. So this becomes -4 plus 3, because this will become positive. Okay, so that's why the answer is -1. So we have here our minimum, and this is our maximum. There's no need for you to do this. I'm just showing this for you to see actually what I'm doing to get -7 and -1. So again, to get -7, the minimum, that is d minus the absolute value of a. So our d is -4. You have -4 here, minus is always minus here, and the absolute value of -3. Now the absolute value of any number is positive, so this becomes -4 minus +3. Okay, the -3 here becomes +3. And for the second one, we have d plus the absolute value of a. We have our d is -4 plus the absolute value of -3. That becomes -4 plus, this will become positive, so +3. The absolute value of -3 is 3. So -4 plus 3 is equal to -1. So this is -4 minus 3. And the second one is -4 plus 3. Okay. And the period is always equal to 360 over b, or b is 5. Now, if b is -5, that will become +5. It's always positive. Okay. Now, if c is 0, immediately we can create our table. We have the x, then we have x in radian, because Excel actually understands only radian. So we're going to convert all our degrees into radians. And here is our y, that is our f of x. Okay, so we can start with 0, and then next one is 72 multiply 0.25. So as you can see, the difference is 18. So you can have this equals 18 plus 18. 36 and drag it down. Okay. Or you can, change this by having 75 times 0.5 to become 36. But there's no need. The shortcut is we can start with 0 because we don't have c. Our c is 0. We have c, but it is 0. Now we start with 0 and then equals here 72. That is 1 period times 0.25 is 1/4. So as you can see, the difference is 18. So equals this plus 18 again. Keep on adding by 18. But there's no need to continue doing it manually. Just select 36 and drag it down. It will keep on adding by 18. 36 plus 18, 54 plus 18, and so on. Actually, we can stop here. But to see the behavior of the graph, we can add more points, and you can keep on adding if you want to, because this is actually until infinity. So here equals radians of this. We start with the first only and drag it down. So we have converted all our degrees into radians. Okay, so 180 is equal to pi 3.14159 something. Now to solve for our f of x, our y, we have to follow this function. We have -3 multiply sine. Then we have 5 multiply our x. We're going to choose the one in radian. Okay, and close minus 4. So I have to drag it down. Right? As you can see, we have -1 and -7. As I said, because our c is 0. If c is 0, immediately we can get the minimum and the maximum. So to graph, we have to select the last two columns, insert, and the second one. So this is our graph. And as you can see, we don't have our x-intercepts because it's not touching our x-line or x-axis. The x-line is here, okay, starting from 0. Okay, so you can write no x-intercepts. Right, so I guess this one is very easy. I want you to, keep on watching this particular video. Try to rewind, pause, and forward if you want to learn better. For number 2, we have here our function where we have complete A, B, C, and D. So our A is 3, our B is 2, C is 7, and our D is -3. So we have 3, 2, 7, -3. The minimum equals D, that is -3. You can also highlight it, minus A. Our A is already positive, so just write, -3 directly. And here we have D, or you can write -3 plus our A3. So the maximum is 0. Our period is equal to 360 over B, which is 2. So we have 180. Now, in this case, we will not be getting our maximum and minimum directly. So we need to look at the values given here. Okay, our minimum is -6, and we have 0. If you're going to try it, see, if you're going to start from 0, for example, and then here equals 180 times 0.25, 45 is a difference, so equals 45 plus 45, and drag it down. And here equals radians. This, drag it down. Now, our y is equal to 3 times sine. We have 2 multiply our x, close, here plus 7, and then -3. So drag it down. See, we are not able to get our minimum and our maximum. Right? So what we're going to do actually is not to follow this method. If we have 3, 2, 7, -3, we don't have 0 here as our C. We have complete set of A, B, C, and D. What we're going to do is to actually use our maximum or our minimum. Okay, so let's try our minimum. -6 equals, using the function, we have 3 sine 2x plus 7 minus 3. So we are changing our, so we have to put a space here so we can write. So our y changed to the minimum, so -6 equals the whole expression on the right. So that will become -9 equals 3 sine 2x plus 7, okay, minus, so 3 negative is transferred to the other side. So this becomes -6 plus 3. Sorry. Okay, so -6 and then -3 becomes +3. That is actually equal to -3 base equals 3 sine 2x plus 7. Okay, right here. Then now we are going to divide. We have, or directly we can have, a sine of -1 equals 2x plus 7. Okay, so we transfer our sign to the other side. That will become a sine, and -3 divided by 3 is equal to -1. So a sine, that means arc sine of -1 is equal to -1.57 something. That is equal to 2x plus 7. Okay, so you have to put a space here before equal sign. And this will be equal to this minus 7. Because we transfer 7 to the other side, then we have to divide this by 2 because we have 2x to find our x. Okay? So again, we have here negative 1.5 something minus 7, and then we divide by 2 to solve our x. So this in degrees, all right, negative 245. So here we can have equals this. Okay, then equals this one plus 0.25 times our period is 180. So what is the difference between the two? Equals this minus this, 45. So this plus 45 and drag it down. Okay. So these are the values. And equals radians of this, drag it down. Now we can solve for our y equals following this 3 times sine. We have 2 multiply x. This is our x, the radian. I cannot highlight, so this is L3. This is 3 and L, so you can write L3 if you cannot see it. A plus 7 minus 3. So we have negative 6. As you can see, that is our minimum. And drag it down. As you can see, we have negative 6 and 0 there as our minimum and maximum. So this is what you're going to do if we have A, B, C, and D completely, and C, of course, not 0. So we have to highlight this, insert, second one. So as you can see, our x-intercepts are along the x-axis. Now, if you're going to change the layout to number 5, you can see that our minimum is negative 6, our maximum is 0. Okay, so you can try this in Desmos as well. Later, I'm going to show you how to find the x-intercept of this particular function. Or we say x-intercepts because you have more than one actually because it is periodic. Okay, so let's try this in Desmos. For example, we have y equals 3 sine 2x plus 7 minus 3. So in Desmos, this is y equals, we have 3 sine, okay, 5x, this is 2x plus 7 minus 3. Okay, so as you can see here, we have our first x-intercept followed by this one. So as I said, the x-intercepts are along the x-line. This and this and this one, okay? So it is the same here. We have 0.271, 0.43, and we have 3.57. This is, 4 to 7 is 43. So 0.427 is 0.43. This is negative 2.7, and here 3.56 or 3.6 or 3.57 to 2 decimal places. So it's exactly the same. All right. So later I'll be showing you how to solve the x-intercepts. Okay, so this video is particularly on how to graph the sine or cosine function. Later, I'm going to show you how to find the x-intercepts. So thank you so much for watching. Until the next time, bye-bye.